Hello everyone. Do you hear me? Okay, good. Okay, let's start. So, hello everyone. I'm pleased that you are made today to attend this webinar around the blockchain technology, its applications, and its business value. Who am I? I'm an engineer in information sciences and technologies and a PhD in machine learning with a specialization in deep learning and reinforcement learning. I'm also the data scientist of Pentalog and a consultant in big data architectures and technologies. And I'm responsible of the R&D of Pentalog, and actually are focused on the blockchain technologies. So the content, this talk will contain three essential parts. First, what are blockchain technologies? Why is it relevant for business? And how can we apply the blockchain? First part. So I will begin by presenting technological foundation on which is based the blockchain. The first technology is the peer-to-peer network, which is a network of users who interact as equals, peers. It's different from a traditional server-based networks in that there is no central point of control that is in charge of the network. This makes it difficult to shut down or restrict, yet easy to set up without having to invest large sums of money in servers. The second technology is not really technology, but a theory. It is the asymmetric cryptography. I think in 1976, U.S. researchers Diffie and Hillman present the revolutionary concept of dual public and private key. The Diffie-Hellman protocol allows two agents to exchange between them in an encrypted form without needing a password. So this innovation is the genesis of blockchain technology. Asymmetric cryptography uses public and private keys to encrypt and decrypt data. The keys are simply large numbers that have been paired together, but are not identical. That's why we call it asymmetric. One key in the pair can be shared with everyone, the public key, and the other key, the private key, is kept secret. Security depends on the secrecy of the private key. So this theoretical innovation is coupled with an exponential increase in computing power combined with the availability of the computing units, the cloud computing, and cryptography available to all and virtually unbreakable was born. In parallel, distributed architectures have emerged as a reference in terms of stability and security. The best example is the web, HTML. So cryptography and distributed architectures are generating scratch confidence. They will converge together to form the technological layer of Bitcoin, which is the blockchain. Let's go a little to business, which is more simple. So business networks benefit from connectivity, have connected customers, suppliers, bank partners, and wealth is generated by the flow of goods and services across business network. Both public and private marks are central to this process. Some definitions. Anything that is capable of being owned or controlled to produce value is an asset. Have two fundamental types of asset: tangible, like house, or intangible. Intangible assets subdivide into financial, intellectual, like patents, or digital, for example, music. And even cash is also an asset, and it has property of anonymity. In the business network, ledgers are important. A ledger is the system of record for a business. It records asset transfer between participants. So business will have multiple ledgers for multiple business networks in which they participate. We have also participants which are members of the business network. customers, suppliers, government, regulator. They usually reside in an organization and has specific identities and roles. Transaction is an asset transfer. For example, John gives a car to Anthony. And a contract is a set of conditions for transaction to occur. For example, if Anthony pays Johnny money, then the car passes from Johnny to Anthony, which is simple. So the blockchain is a global distributed ledger which facilitates the movement of assets across the world in seconds with only a minimal transaction fee. These assets can be any type of value as long as they can be represented. There is a problem which is difficult to monitor asset ownership and transfers in a trusted business network. Up until Bitcoin and its distributed ledger was invented, digital currencies were seen as infeasible due to the relative ease of which digital information can be copied. This is known as the double spending problem, where each transaction carries a risk of the holder sending a copy of the digital coin to the merchant while retaining the original. So the traditional way of mitigating the risk has been to have a trusted third party, such as a bank or an intermediary, to act as a centralized authority keeping track of all transactions. And the solution is a permissioned replicated shared ledger. So Bitcoin has shifted this responsibility to a whole network. To exchange ownership of a digital coin, a centralized database is no longer required. Instead, a distributed ledger keeps a history of all transactions and requires validation from its user to verify each change of ownership. This is a simplified illustration of a distributed ledger network. So each member of the network, called a node, holds a chain of blocks which constitutes a total history of transactions performed on the network. And each block holds a set of transactions, which size depends on how many transactions were completed in a given time interval. So how does it work? Transaction definition. So the sender creates a transaction, transmits it to the network. The transaction message includes details of the receiver's public address, the value of the transaction, and a cryptographic digital signature that proves the authenticity of the transaction. Then the nodes, computers or users of the network, receive the message and authenticate the validity of the message by decrypting the digital signature. And the authenticated transaction is placed in a pool of pending transactions. Then these pending transactions are put together in an updated version of the ledger called a block by one of the nodes in the network. So at a specific time interval, the nodes broadcast the block to the network for validation. The validator nodes of the network receive the proposed block and work to validate it through an iterative process, complicated iterative process to solve a cryptographic problem, which requires consensus from a majority of networks. Different blockchain networks use different validation techniques. For example, Bitcoin's blockchain uses a technique called proof of work. Ripple use distributed consensus, and Ethereum use a proof of stake. So the various techniques have different pros and cons. And the common denominator is that they ensure that every transaction is valid and make fraudulent transaction possible. And finally, the blockchaining. So if all transactions are validated, the new block is chained into the blockchain, is added into the blockchain, and the new current state of the ledger is broadcast to the network. This whole process can be complete, I think, between 3 and 10 seconds. So blockchain for the business, we have seen shared ledger, privacy, validation, and there is another essential part, which is smart contract. Business rules implied by the contract. So smart contract is embedded in the blockchain and executed with the transaction. Is verifiable and signed, and it's encoded in a programming language. For example, defines contractual conditions under which corporate band transfer occurs. The second part, why is it relevant for our business? So there is a lot of benefits of blockchain technology. First, it ensures disintermediation and trustless exchange. Two parties are able to make an exchange without the oversight of intermediation of a third party, strongly reducing or even eliminating counterparty risk. Also, users are in control of all their information and transaction. And blockchain data is complete, consistent, timely, accurate, and widely available. And due to the decentralized networks, blockchain does not have a central point of failure and is better able to withstand malicious attacks. And user can trust the transaction will be executed exactly as the protocol commands, removing the need for a trusted third party. Furthermore, changes to public blockchains are publicly viewable by all parties, creating transparency, and all transactions are immutable. That means that they cannot be altered or deleted. And blockchain also ensures ecosystem simplifications. With all transactions being added to a single public ledger, it reduces the clutter and complication of multiple ledgers. And we have also a faster transaction, and in addition, by eliminating third-party intermediaries and overhead costs for exchanging assets, blockchain have the potential to greatly reduce the transaction fees. So, as we enter the second generation of Internet, which focuses on value as well as information, blockchains may logically drop many transaction costs. For example, a global searchable database of all transactions would dramatically lower the cost of search. So smart contracts on blockchain will plummet the costs of contracting, enforcing contracts, and making payments. And also autonomous agents on the blockchain hold the promise of eliminating agency and coordinated costs, and can perhaps even lead to highly distributed enterprise with little or no management. That's what we call today decentralized autonomous organization. Consider, for example, I will consider an example of the music industry, where intermediaries capture nearly all the value and artists get paid last. So now companies like Mycelia have developed intelligent songs with smart contracts built in, which enable artists to sell directly to consumers without going through a label. Through a label, a financial intermediary, or technology company. So this means that royalties and licensing agreements execute automatically and instantly, and artists get paid first. I think Spotify, Apple, Sony Music, and other massive media companies stand to lose or gain depending on how quickly they embrace this technology. So, blockchain technology can also network the business models to a new level by supporting a whole host of breakthrough applications. For example, net payment systems that run without banks, credit cards companies, and other intermediaries will cut cost and time from transactions. Also, reputation systems built on social and economic capital and controlled by individuals rather than by intermediaries like a rating agency and credit rating services will change the dynamic between consumers and company. Trustless transaction where two or more people need not know nor trust each other to do business will be feasible. But blockchain, be careful, is not suitable for all. So there is negative indicators, needs high performance transactions, small organizations, no business network, and it's not suitable for those who are looking for a database replacement, looking for a messaging solution, looking for transaction processing replacement. This is a cartography of the most important use case in finance with the most successful startup. Most investment has focused on the financial sector. 30 of the world's biggest banks have joined the consortium to build the blockchain solutions. And Nasdaq is working on blockchain-powered private market exchange. So business that deal with slow, costly, and unreliable transaction, or that serve markets with underdeveloped payment systems, or a lot of banking customers, have good reason to consider distributed ledger technology. So blockchain benefits are really many, such as reliability, availability, transparency, and all the benefits that I talked about. The attractiveness of blockchain can best be gauged by the kind of attention it garners from startups and incumbents alike, especially in banking and finance. Areas of focus for banks and startups can include cross-border payments, trading activities, custody service, and customer behavior analysis. Santander, for example, seems to have identified 20 to 25 use cases with a focus on international payments and smart contracts. Barclays is focusing on 45 internal use case experiments, while Citibank has created its own version of Bitcoin called Citicoin. But beyond the financial sector, blockchain investments are emerging in every major industry. And Microsoft has deployed a cloud-based blockchain as a service. So beyond Bitcoin, blockchain is coming to disrupt industry. I will focus on blockchain's application in different industries. Industries besides the financial sector include media, consumer products, automobiles, travel, hospitality, retail, healthcare, government, energy. And startups focusing on non-financial use cases have seen a jump in numbers, with several new entities entering the space in 2015. The emerging this cartography suggests that non-financial use case outnumber financial ones, indicating that real-world assets could increasingly be linked to blockchain and trade. So I will talk about the telecom use. The media and telecommunication industry offer use case. Media sector applications include supporting low-cost microtransaction that can be proceeded without the fees that existing payment networks require. So a newspaper website, for example, can charge readers per page or per article rather than per month. So the blockchain can secure intellectual property and creative digital products like music and images. A blockchain ledger can be a reliable and secure way to prove a work's provenance and attribution. So the digital blocks programmability makes it possible to enforce users' rights. For example, IBM and Samsung have offered a proof of concept built part using Ethereum, which is the blockchain dedicated to develop decentralized applications. And they have built proof of concept to demonstrate how blockchain can support Internet of Things, IoT applications, by supporting a transaction processing device. The distributed nature of the ledger can foster coordination among multiple devices. I'll take an example, but really there is a great potential for the blockchain to be combined with Internet of Things. For instance, a refrigerator equipped with sensors and connected to the internet could use blockchain to manage automated interaction with the external world, ordering and paying for food, to arranging for its own software upgrades and tracking its warranty, for example. In addition, the cryptographic security that blockchains rely on can reduce the security channels that IoT deployments face. For example, Verizon Ventures, a division of Verizon Communication, has invested in a startup that has raised $5 million exploring blockchain-enabled IoT applications. Orange has also invested in a blockchain startup. Alternative retail payment platforms is the most obvious application in the consumer and industrial products arenas. There is another application which are more futuristic, I think. For example, DocuSign, which provides digital transaction management and electronic signature technology, developed an app for Visa connected card but it's still a proof of concept. So the app integrates with the Bitcoin blockchain and records contracts. And the application is designed to simplify auto purchasing and leasing. For travel and hospitality, a shared distributed ledger can simplify the settlement process. Blockchain technology can support loyalty points programs that include a more advantageous accounting of liabilities created by the accrual of points, real-time updating of points balances, and improved points management across franchised operations. Also using digital signatures on blockchain-based data that allows access only when authorized by multiple people could regulate the availability and maintain the privacy of health records. In addition, a community of people, including hospitals, doctors, patients, and insurance companies, could be part of the overall blockchain, reducing fraud in healthcare payments. So in healthcare and life science, blockchain technology can secure digital assets. For example, Factum, a blockchain-based record-keeping service, has partnered with medical procedure billing and ordering service. The partnerships will use blockchain to store healthcare records, and the cryptographic security can enhance records security, while the irrevocable and immutable nature of transaction can make claims processing more efficient. So blockchain-secured health records could make it easier for patients to share records with numerous providers while keeping control of the records. Philips, also we can take the example of Philips Healthcare, which is exploring application for blockchain technology, but it has not disclosed the application it's evaluating. Successful applications will create new parallel ecosystems with a base of incumbent users or completely new actors. An example might be a corporate bond ledger looking to introduce cheaper and more efficient ways to trade bonds. This initiative could start as niche applications focusing on issuers priced out of existing mechanisms. However, if it proved cheaper and more efficient in time, issuers might be attracted to the cheaper ledger. So after a while, the market could reach a point where the bond ledger became so attractive to all issuers that bonds are only issued using the technology. There is another potential use case in securities, trade finance, syndicated loans, retail banking, and we can imagine an infinite set of applications. So now I will pass to the last part. How can we apply blockchain? So before you embark on a blockchain project, you need to have a very clear idea of why you are using blockchain. There are a bunch of conditions that need to be fulfilled, and if they are not, you should go back to the drawing board. Maybe you can define the project better, or maybe you can save everyone a load of time and money, because you don't need really a blockchain technology. So the first condition is the database. Blockchains are a technology for shared database. So you need to start by knowing why you are using a database, by which I mean a sectional repository of information. So this can be a traditional relational database or even not only SQL variety. So databases are modified via transaction, which represent a set of chains to the database which must be accepted or rejected as a whole. For example, in the case of an asset ledger, a payment from one user to another is represented by a transaction that deducts the appropriate quantity from one row and adds it to another. Second condition is easy and is multiple writers. Blockchain are technology for database with multiple writes. In other words, there needs to be more than one entity which is generating the transaction that modifies the database. So do you know how these writes are? In most cases, the writers will also run nodes which hold the copy of the database and relay transaction to other nodes in a peer-to-peer fashion. That's what we talk. That's what I talked about in the last section. However, transaction might also be created by a user who are not running a node themselves. For example, consider, for example, payment system, which is collectively maintained by a small group of banks, but has millions of end users on mobile devices communicating only with their own bank system. The third condition is the absence of trust. And it's the third rule. If multiple entities are writing to the database, there is also needs to be some degree of mistrust between those entities. In other words, blockchains are a technology for database with multiple non-trusting rights. So what do I specifically mean by mistrust? I mean that one user is not willing to let another modify database entries which is owns, and similarly, when it comes to reading the database content, one user will not accept as a gospel the truth as reported by another user, because each has different economic and political incentives. The rule number 4 is the disintermediation. So blockchain removes the need for trusted intermediaries by enabling databases with multiple non-trusting writers to be modified directly. So no central gatekeeper is required to verify transaction and authenticate their source. Instead, the definition of transaction is extended to include a proof of authorizations and a proof of validity. Transaction can therefore be independently verified and processed by every node which maintains a copy of the database. But the question you need to ask is, do you want or need this disintermediation? Given your use case, is there anything wrong with having a central party who maintains an authoritative database and acts as the transaction gatekeeper? The good reason to prefer blockchain-based database over a trusted intermediary might include lower costs, faster transaction, all benefits that I listed in the last section. The rule number 5 is the transaction interaction. Blockchains make sense for databases that are shared by multiple rights who don't entirely trust each other and who modify that database directly. But that's still not enough, because blockchains truly shine where there is some interaction between the transaction created by these writers. What I mean by interaction in the fullest sense, this means that transactions created by different writers often depend on one another. For example, let's say Alice sends some funds to Bob, and then Bob sends some to Charlie. In this case, Bob's transaction is dependent on Alice's transaction, and there is no way to verify Bob's transaction without checking Alice first. So because of this dependency, the transaction naturally belong together in a single shared database. The rule number 6, this isn't really a condition, this isn't really a rule, but rather an inevitable consequence of the previous point. If we have a database modified directly by multiple writers, and those writers don't fully trust each other, then the database must contain embedded rules restricting the transaction performed. These rules are fundamentally different from the concepts that appear in a traditional database because they relate to the legitimacy of transformations rather than the state of the database at a particular point in time. So every transaction is checked against these rules by every node in the network, and those that fail are rejected and not relied on. If your project not fulfill every single one of these conditions, you should not be using a blockchain. In the absence of any of the first 5, you should consider one of regular file storage, for example, centralized database, a master-slave database applications, or multiple database to which users can subscribe. And if you do fulfill the first 5 conditions, there is still work to do. You need to be able to express the rules of your application in terms of the transaction which a database allows. You need to be confident about who you can trust as validators and how you will define the distributed majority consensus. And finally, if you are looking at creating a shared ledger, you need to know who will be backing the assets which that ledger represents. So if you got all the answers, congratulations, you have a real blockchain use case. And I invite you to participate in the Startup Weekend, the first in the world about the blockchain thematic, which will be organized by Pentalog in the month of January. And if you have other questions, I invite you also to download my white paper about blockchains. You can find it in Technology Method. In the blog Technology Method of Pentalog. So, to conclude, blockchain is a shared replicated ledger technology, which it can open up business networks by taking out costs, improving efficiency, and increase accessibilities. And blockchain addresses an existing and topical set of business challenges which cross every industry. So thank you for your attention, and I invite you to put questions in the chat. I will try to answer. Yeah, the slide will be available for later viewing. Can blockchain be used for auditing? Okay, it's a good question. So since the blockchain is an append-only log of all transactions that ever happened, the act of sending a transaction also creates the records of the transaction in the blockchain. So to allow someone to audit your finances, you can now simply provide them with a list of all your addresses and records about the transaction to provide full transparency. Naturally, since fiat cannot be transferred with Bitcoin directly, this does not help to audit fiat payments. However, there are some service building on the top of Bitcoin, such as cold coin systems, that allow to transfer denominated IOUs, and this transaction could be audited similarly as regular Bitcoin transactions. Please, please elaborate on telecom application. I don't. Please elaborate on telecom application. Telecom applications. You need to. You want that I list some applications of blockchain in the field of telecommunication. Now there is a lot of application. A lot of application to each case can use a property of blockchain. If you want to use the disintermediation, if you want to use the security, if you want to use the absence of trust. So we can imagine an infinite number of applications in every field. For DocuSign, developed an application for Visa connected car proof of concept. So the application integrates with the Bitcoin blockchain and records contract. And the application is designed to simplify auto purchasing and leasing, but it's still a proof of concept. They still in a proof of concept phases. Okay, so I will wait for 5 minutes yet, and I will disconnect. So if you have other questions. For slides, I think a repetition of this webinar will be available on the website of Pentalog, and for the health care providers. For the healthcare providers, there is a lot of for example, we can secure digital assets in the field of healthcare. You must, if you want know more details, the application of the blockchains in the healthcare fields. I invite you to see what Factum do now in this field. But all the applications are based on this security property of the blockchain. Which blockchain platform is good for experimenting? So for me, there is two families of blockchain. There is blockchains which are more specialized for cryptocurrency, and there is Ethereum, which is a very good platform to develop smart contract and to develop decentralized application. You will find a lot of detail in the white paper if you will, if you will download it. So thank you for your attention, and if you need one-to-one meeting, you can take contact with me. I will be available for you for other questions. You can send me your question by emailing, and you can put comments in the repetitions of this webinar. Yeah, just to answer your question for the supply chain, yeah, I think that that actors of a supply chain will collaborate and share their ledger, and there is a lot of applications of blockchain in the supply chain. So thank you for your attention, and thank you to be here today, and see you for other webinars.